Hey A&Pers, this is Dr. Jones checking in. This is A&P 1, Lecture Test 1, Video 12. And we are starting Chapter 3, which for me is the top of page 19. Chapter 3. Alright, so let me write down that we're on Video 12. 12. Noteset, page 19. Alright. Happy to see y'all virtually back. Let's dig in. So first we're talking about the basic concepts of cell theory, and we've got some bullets here, and I'll read you what I have written down. Again, it might be pretty much what's in the book. It might be a little different. If you can understand the jargon and have a good English explanation, or whatever your preferred language is, explanation in your head that is non-jargony, where you can explain it to a 5-year-old, then you're good to go. But you still need to be able to answer the test questions, which are written in the same jargon as the book. Quick hint, as normally people have asked me by now, but kind of recording these on my own. In the back of each chapter, I'm flipping through this gargantuan book here. Let's see, right at the end of the chapter, if I can find one, we've got a chapter review, which is a great review. And then, and this one's chapter 5, there are some review questions. And these, in very small font, but these review questions are written in the same type of jargon that you will find in our questions for the tests, mostly because the majority of my questions come out of the test bank, which is where these questions come from also. So, all right, so cells are the building blocks of life, first bullet. Second bullet, cells come from the division of living cells, which is mitosis, which we will learn about. And again, we are also covering mitosis in lab. So the majority of lab 1 material you also need to know for test 1. Lab 1 and test 1 tend to be on the same week. Every semester is a little different though, so no promises. But it makes sense to study both together because they are related. They complement each other with an E, which I think we talked about. I don't remember. And cells are the smallest units of life. And last bullet, each cell maintains homeostasis. Another word for last is ultimate. So the ultimate bullet is that each cell maintains homeostasis. So there's actually another word that I like to use for the next to last in any list, and that is the penultimate. And so I usually lose track of which bullet I'm on, but I can always see next to last. So I tend to call it the penultimate bullet. When I say that, I'm pointing you to the next to last bullet. And then the ultimate bullet is the last one on the list. So you know. What is the study of cells called? We've covered this. You know it. It's right? Because cyto means cell and ology is the study of. So cytology is the study of cells. And the two general classes of cells are sex cells and somatic cells. So, nope, that's not a pen. Kind of like the green. Okay, so there are sex cells with a C. I mean, if you're in advertising, then you do sex cells, but with an S here instead of a C, but we're doing with a C. Sex cells and somatic cells, S-O-M-A-T-I-C, somatic cells. And soma means body. So we're going to see this soma as a word root a lot in both A&P 1 and A&P 2, and it will generally refer to the main portion, the body. Sex cells and somatic cells, and there are two types of sex cells. Eggs. That was a terrible G. Look more like an S. And sperm. And then yes, that's a P. And the technical term for egg, since it's in your book and you are going to need to know next semester, is an oocyte or an oocyte. There you go. Again, I'm writing with a mouse. It's terrible. I know it's terrible, and I apologize. Okay, which general classes of cells are we studying? Somatic cells. We are not going to study sex cells, eggs, and sperm, which are made by meiosis, until the end of 2402 for test 6, when we talk about reproductive and development, which I tend to call sex and babies. We are talking about somatic cells. So what are your somatic cells? It's literally every cell of your body that's neither an egg cell nor a sperm cell. So the cells that grow your hair, your skin cells, your liver cells, your bone cells, your pancreas cells, your heart cells, your blood vessel wall cells, your blood cells, literally all of the cells in your body that are neither an egg nor a sperm. Okay, so how do you make somatic cells? Have we talked about mitosis yet? Oh yeah, it was the second bullet. Okay, so the second bullet, I said it, so let me spell it for you. It's what my 14-year-old says when the 11-year-old steps on his foot. My toe, sis. I know, it was terrible. The terrible ones are my favorites. And we're covering the jokes as part of your curriculum, so live with it. Okay, I have another science joke that's early in the semester, but not till 2402, so I'll go ahead and tell you because there's a story. So our eyes see, let me move this down, like barely fitting in the screen. Okay, so our eyes see the little packets of light that travel. Little packets of light called photons, and that's how light travels, as photons, and they like radiate, right? Because light radiates out. And so there's a joke that a photon went to check into the hotel and was asked if he had any luggage, and the photon said, "No, I'm traveling light." And so the funny part is when I tell you all these jokes, usually they're in my head, and so then I tell my kids the jokes. And the funny part is when my kids go then tell my in-laws the joke. Okay, that's not the funny part. The funny part is the next 10 minutes where they explain the science to my in-laws. That's my favorite part. Every time. They won't listen to it from me, but they will listen to the grandkids. So science jokes are very useful for the teaching of science, I maintain. We're going with it. 4 general functions of the plasma membrane. All right, so now we're talking about the cell membrane. It's called the plasma membrane. It's also called the cell membrane, and it's sometimes called the plasma lemma. And we will find this lemma root used over and over again with to differentiate between different types of cell membranes. So all cell membranes are plasma lemmas, and then our muscle cell membranes are going to be like sarcolemma, and then the axon membrane is going to be a neurolemma, and we'll get there. But for now, we need the plasma membrane, cell membrane, and plasma lemma. Lemma here means husk. And it has 4 general functions. So let me tell you what these 4 bullets are. First bullet, physical isolation. The cell membrane keeps the good stuff in and the bad stuff out. Physical isolation. It determines what's inside the cell and what's outside the cell. Very important. Second bullet, regulation of exchange with the environment. So sometimes there's something outside that you want to let into the cell, and it's the cell membrane's job to determine that and do that to it. It allows for transport across the membrane. And there are different ways to do that, and we'll mention that briefly before for this test. Yeah, the end of this chapter. Number 3 is the penultimate bullet. Number 3 is sensitivity to the environment, and this will be receptors. So there are receptors on the cell membrane that read, air quotes, if you will, what's in the environment surrounding the cell. So it monitors the external environment. And 4 is structural support, and we're largely glossing over that part of this chapter. So it's pretty interesting, but not anything that we directly need much of for this semester. So the plasma lemma we mentioned in a previous video is a phospholipid bilayer. So here are our phospholipids. We have our hydrophilic heads and hydrophobic tails. And here's one layer of phospholipids, and here's our second layer of phospholipids. So we have a phospholipid bilayer. So you may notice that the hydrophobic tails, oh, yeah, you need to know that, are facing each other. So what happens is this extracellular fluid is an aqueous fluid, aqueous, which means it's a water-based fluid. And this is outside the cell. It is a water-based, like agua, water-based fluid. And the cytoplasm inside the cell is also an aqueous fluid. And so the hydrophobic tails are repelled by the water on either side. And so they make a little fat layer. And so this sandwiched layer of fats in between the two layers of hydrophilic heads makes a mostly impermeable barrier, meaning things can't just cross it. So anything floating in the water can't just go through this fatty, oily layer. Except. Okay, and then draw a phospholipid. Okay, and label it. And then draw a phospholipid bilayer. There you go, a phospholipid bilayer with hydrophilic heads and hydrophobic tails. Okay, and integral transmembrane proteins are these. Okay, get me out of the way. All right, so these are integral proteins, and they are integrated into the membrane, and they cross the membrane. Okay, you see how they stick out both sides? That's what makes it an integral protein, transmembrane protein. It spans the width of the membrane. And a channel protein is an integral protein with a channel, a pore, a hole in it, so that things can cross. And these tend to be very specific. Like if this is a potassium leak channel, then only potassium can cross. If it's a sodium leak channel, only sodium can cross. And so there are channels with proteins with channels that allow things, I don't want to make a list. There are things that can cross the membrane, but it depends on the nature of the channel. Okay, and then I need you to add gated channel to the bottom of page 19, right above where it says figure 3.2 plasma membrane, or below, wherever it fits for you. So some of these channel proteins have a gate where if something binds here, then that changes the shape of the protein and opens this gate and allows things to move through, to go from outside to inside or inside to outside to cross the membrane. Okay. And we will spend a lot of time talking about crossing membranes. We'll come back to that. Okay. Next page, audible page turning noises. Moving on to top of page 20 with the word cytoplasm. Let's move me out of the way. Cytoplasm is everything between the nuclear envelope and the cell membrane. I said this in the previous video. I will say it again. If you are not already familiar with the cell parts from lab, go catch up on lab. And then come back. So the cytoplasm is everything between this nuclear envelope and the cell membrane. So all of this is cytoplasm. And cytosol is the intracellular fluid. It's the fluid inside the cell. So let's talk quickly about the difference between does not equal, it was supposed to be an intra. Okay, so it's the difference between internet and intranet. Internet connects you to the entire rest of the world. It's between you and everyone else. And the intranet is just like what's hooked up by Ethernet cords inside your house on your own specific system. Okay, so like if you're at school and you're messaging someone else at school, you're on the intranet if you're using their system. Another example, like in grade school, you play intramural sports, where you're playing volleyball against other kids from your own school. And then when you get into junior high, then you play intramural sports, where you're playing kids from other schools. So, like an interstate highway goes between two states. All right, so the cytosol is the intracellular fluid because it's the fluid inside the cell, and it is an aqueous liquid. That it's aqueous. And I see like a little fly, like one of the little bitty like no-see-ums. Okay, and then the solid bits inside the cell are called organelles. And the organelles are functional structures in the cytosol, so the solid bits. And like the nucleus is considered an organelle and not considered an organelle, and it's one of those things. So cytoplasm equals, you got it, cytosol plus organelles. Y'all are answering out loud, aren't you? As long as you're not going to wake anybody up. Like if the baby is sleeping, never, ever, ever wake a baby. If you have time, the best plan is if the baby's asleep, you're asleep. I could not sleep when my kids were late or awake until they were like, I don't even know. Like it felt ridiculously old that I did not need to be awake all the time when they were awake, but I still was. It happens. Okay, next slide. There it is. Cytosol. What's the difference between the cytosol, the intracellular fluid, and the interstitial fluid, which is the extracellular fluid? And the answer is location, location, location. The cytosol, the intracellular fluid, is inside the cell. And the interstitial fluid is another word for extracellular fluid, and that is outside the cell. And there are some technical differences between extracellular fluid and interstitial fluid, and that's beyond the scope of this class. So for us, interstitial fluid is extracellular fluid and vice versa. With the understanding that at some point you might need to know the difference, but probably not. Okay, so is the concentration of potassium ions higher inside the cell or outside the cell? It is higher inside the cell. K+ is potassium. Is the concentration of sodium ions Na plus higher inside the cell or outside the cell? Outside the cell. Is a concentration of proteins higher inside the cell or outside the cell? Inside the cell. Pretty much there shouldn't be any outside the cell, kind of, mostly. Yeah. And then the intracellular fluid, the cytosol, also contains carbs. Carbs are used to provide energy. Remember, carbs were sugars and starches. Glucose is your main metabolic fuel, but and then the starches will be like stored sugars. Amino acids are used to synthesize, which means make proteins. Amino acids are the building blocks of proteins. And lipids are used as backup energy. So these are reserves. Although the body can use protein as backup energy. So, all right, and then we have a picture. Here, write this down real quick. Oh, wait a second, while you pause. Okay, that was fun. The inside of the cell has a slight negative charge compared to the outside the cell. So we are going to, I'm kind of digging the green, so we're going to black screen this time. Ooh, hello, that's fun. All right, so I'm going to draw a cell. That's a circle. We're going with that it's a circle. Okay, so that's our cell. So this is the cytosol. Okay, and then this is the interstitial fluid. I bet cursive would be easier. Can y'all read cursive? Can you like put in the comments if you can or cannot read cursive? Because I need an informal poll here. Okay, so we said that potassium concentrations are higher inside the cell than outside the cell. So I'm going to draw a couple of potassium inside the cell and one outside the cell. In no way is this the actual ratio. This is only emblematic. It's representative of the fact that there's more potassium inside the cell than outside the cell. Okay, and then sodium, which is Na plus. There's more sodium outside the cell than inside the cell. Again, not a 3-to-1 ratio. I'm only showing that there's more outside than inside. Okay. And then proteins, which are negative, are higher inside the cell. And kind of shouldn't be any outside the cell. And so that, along with a few other things. Oh, my cord moved and it startled me. Oh, I must have bumped it. My cord is like in the shadow on my desk and it just moved. Oh, excuse me. Okay, so because proteins are negative and there's more inside the cell than outside the cell, the inside of the cell is relatively negatively charged compared to the outside of the cell. The outside of the cell is relatively positive, the inside of the cell is relatively negative, and so they're kind of attracted to each other, but there's a membrane separating that difference in charges. It's still moving. Okay. I'm gonna plug something in so that this charge cord won't move. It's a really pretty charge cord. It's pink sparkles and it's got this thing on it, and so this like Velcro bit shifting apparently is a startle factor for me. Who knew? All right, so we will finish this page and call this a video. All right, so the inside of the cell is relatively negative compared to the outside of the cell. So I gotta tell you, at the beginning of 2402, I draw this on the board and we have a nice old-fashioned review because there's not maybe one chapter in the book where you don't need to know this off the top of your head. Third blink means I'm serious. Okay. So that's the thing with this first bit, is like there's so much all at once, and it's like all need to know, every speck of it. So it's like in bold and bigger and like a different color and with 2 sets of asterisks. Like, I don't know how else to tell you that's need to know. If this class is need to know, that is need to know. Okay, what's the difference between a membranous and a non-membranous organelle? The membranous organelles have a membrane, which will be the phospholipid bilayer, same as the cell membrane. And the non-membranous organelles don't. High on the list of things that are completely obvious once I've said them. All right, so the cytoskeleton serves as the cell's skeleton. Again, completely obvious once I've said it. And then we're going to talk about the microvilli, and then we will save the rest of the organelles for the next chapter. In fact, I might start the organelles again just so we'll have an organelle lecture. All right, so microvilli are small finger-shaped projections of the cell membrane. So this is cell membrane, and it makes little fingers here, and the function here is to increase surface area for absorption. That's it, increase surface area for absorption. So you find these in the digestive tract, specifically the small intestine is where you find the majority of them. But we'll do that next semester. Microvilli function to increase surface area for absorption, and they're found lining the digestive tract. They're called a brush border. So when we get to that, you'll know, oh, that's just microvilli. One more thing you need to know, microvilli is the plural. So the singular, which means one, plural, more than one, is a microvillus. 1 microvillus, 2 microvilli. All right, this has been ANP 1, lecture test 1, video 12, and we did 19 and 20. Kind of like doing 2 pages in a video, although sometimes we only get 1. So thank you as always for tuning in. It's nice to digitally see you here. And yeah, education must go on. Dr. J out. Okay, command and then control and then escape.